Okay, so we're kind of coming in late to this video, but we're talking about SOHCAHTOA, sine, cosine, tangent, and what it means. So, you guys, we're just doing cosine of angle T. So if angle T is our reference angle, cosine is adjacent over hypotenuse. What's adjacent to T? What's adjacent to angle T? 15, and hypotenuse is, so you should have had 15 over 17 there. For tangent, we've got tangent of angle T. Still at angle T here. Tangent, SOHCAHTOA, OA, right, is opposite over adjacent. So what's opposite from angle T? 8, and what's adjacent? 15, good. And so tangent of angle G, now we got to switch our reference angle to G. Still tangent, so tangent is still opposite over adjacent. What's opposite of G? And 8. Good. Okay, again, we're never going to use the angle, the right angle as our reference angle. Yep. Yep. Okay, so look at the next page. I would actually like you to write SOHCAHTOA at the top of the next page. SOHCAHTOA. It's pretty important to know how to spell that, because if you spell it wrong, you're going to get the ratios wrong. Okay, so to solve missing sides or angles in a triangle, we're going to use this trigonometry. This problem here, they've labeled 63 degrees. So we're just going to use that as our reference angle. Could we find the other angles? Sure. Could we use the other angle as a reference angle? Yes. But why bother? They already gave us 63, so that's the one we'll use. Now, two sides are labeled, one with an 84 and one with an X. These are the two sides that are of concern to us. One is useful, the other one is the one we're trying to find. 84, is that O, A, or H? H. X, is that O, A, or H? So in other words, opposite or adjacent to 63 degrees? Adjacent. Now, this is the side that we really do not care about. There's no number there. They're not asking us to find it, so we can completely ignore that one. So this problem has to do with the A and the H. So the next thing we need to decide is, are we going to use sine, cosine, or tangent? Well, since this problem deals with A and H, we're going to use cosine, because CAH. This is how we write this problem out. Cosine of, again, what follows is always the angle measure, 63 degrees, equals adjacent over hypotenuse, X over 84. What I want you to do is write that as a proportion. In other words, you're going to put the cosine 63 over 1 so that it looks like a proportion, a ratio equal to a ratio. Now, how do we solve a proportion? Cross multiply. So you're going to do X times 1 is X. Now, in the other direction, we have to be a little careful about how we do this. 84 times the cosine of 63. Now, please keep in mind, the cosine of 63 is a number, but it's a small number. It's less than 1. It's nowhere near 63. There's a big difference between multiplying by 63 and multiplying by the cosine of 63. Okay, so what we're doing on our calculator, there's two ways to do this. If you're careful and you get in the habit, of writing this the way I did, 84 first, and then cos 63. So the whole number first, and then the trig. You could put it exactly that way into your calculator. 84 cosine 63 equals. You don't even have to put a multiplication symbol if you do it that way. And it's 38.14. That's the length of the missing side. Don't forget, you have to make sure that your mode is in degree mode. I have had people take the entire test in the wrong mode, and they get every single question wrong. This is a problem, right? So you got to make sure that you're in the right mode. Now, let's just see. I'm curious. What is the cosine of 63? 0.45399, blah, blah, blah. That is what is equal to the cosine of 63. So we could do cosine 63 and then push equals, and then multiply that by 84. You should get the same answer. The point is, you're really just multiplying two numbers together. You're cross-multiplying. But it's really important to understand that you're not multiplying anything by 63. You're multiplying by the cosine of 63. Okay. Now, what you don't want to do is cosine of 63 times, oops, this calculator is very sensitive, cosine of 63 times 84. What would your calculator actually be doing here? 63 times 84, which is going to be a huge number, and then it's going to try to find the cosine of an angle with that degree. This doesn't end in the right answer, right? So you got to be really careful that you're doing cosine of 63 as a number times 84. Now, you could do cosine 63 in parentheses and then times 84, but like I said, I really think that the best way to do it is get in the habit of doing that 84 first. 84 cos 63. Okay, sorry, I know that was long-winded, but I find that people make a lot of mistakes that way. This is, what was it, 38.14 or something? Was that right? Okay, let's do the next one. This triangle, our reference angle is 42. Is 12 O, A, or H? A. Adjacent to 42, but not the hypotenuse, right? Okay, X is O, A, or H? No. So are we going to use sine, cosine, or tangent? Tangent. So we're going to write tan of 42 over 1 equals opposite over adjacent, X over 12. Cross multiply, you get X equals 12 tan 42. So on your calculator, 12 tan 42, 10.8. And that's meters. These are finding the lengths of the sides. Okay, for number 3, I would like you to set it up as a proportion, but do not solve. Set it up, but do not solve. So you're deciding sine, cosine, or tangent, and you're setting up the ratio on both sides, but please don't solve. All right, so reference angles of 51. This is our H. This is our A. Are we using sine, cosine, or tangent? Cosine. You should have written cosine of 51 over 1 equals 36 over x. Yes, sometimes the x can be on the bottom, right? Because it's opposite over, adjacent over hypotenuse. Hypotenuse has to be on the bottom, and that's our x. So when we cross multiply, what happens? We get x times the cosine of 51 equals 36. This is not a problem. This is just algebra 1. If we want to isolate x, and x is being multiplied by a number, what do? Divide by that number. So x here is just being multiplied by cosine of 51. So what are we going to divide by? Cosine of 51. Again, that's very different than dividing by 51. We're dividing by the cosine of 51. We get x by itself, and on our calculator, we end up doing a division. Yeah, it's pretty sad. I can't remember what the numbers were already. 36 divided by cosine 51. So 36 divided by cos 51. This gives us 57.2, which is our missing side. Any questions on that? So you're setting it up same way, cross multiplying. You just have to realize that if there's an x on the bottom, it ends up a division in your calculator. All right, so the other thing trigonometry can be used for, and right now we're just doing right triangle trigonometry. All of this sine, cosine, tangent business has to do with right triangle trigonometry. O over H. H stands for hypotenuse. There's no such thing as a hypotenuse in any other type of triangle besides a right triangle, right? So don't try SOHCAHTOA on anything but right triangles. There is trigonometry of non-right triangles, but it's not a SOHCAHTOA situation. Okay, these are a little different because we're looking for the angle measure. So this is the other situation that trigonometry can help us with. Finding missing angle measures. Well, if we know that this angle has a side across from it, opposite it, as 23, and a side adjacent to it as 9, we just have to figure out what that ratio is and what angle measure is tied to that ratio. Because remember, we said these ratios are constant. There's only one angle measure that will give you whatever 23 over 9 is. So first, same process. We have O and A, so we're going to use sine, cosine, or tangent. Tangent. And actually, I would like you, this is a mistake here, I would like you to cross out the word proportion. Because I really, when you're looking for the angle measure, I don't want you to use a proportion. I don't want you to put it over 1. Okay, so you got to take notice here. Whenever you're looking for the angle, we're going to use the inverse button. We're not going to cross multiply. So we have tangent of what? X, right? Because it's always the angle measure that follows the trig function. Tangent of x equals opposite over adjacent. 23 over 9. Well, in our calculator, we have to use what's called the inverse button. And that's this second function button, the colored button that you have on your calculator. So we're going to do second tan. And it shows up on the calculator as like a tan to the negative 1. That notation means the inverse tangent. So remember, tangent means the ratio of the opposite over hypotenuse of some angle. Well, here, we already know what the tangent is. What we don't know is what the angle is. So it's like we're doing this kind of in reverse. So now the calculator is asking for the ratio, not the angle measure, the ratio. And that, for us, was 23 over 9. When you push enter, you should get the actual angle measure, 68.63. Okay, so let's add a few things to this here. This is how we originally set it up. Tan of x equals 23 over 9. In your calculator, it looks like this. Tan to the negative 1 of 23 over 9 will equal x. It will equal whatever the angle measure is. So the buttons to push on your calculator. Second, then tan, and then 23 divided by 9. Those are the buttons that we pushed on our calculator. Okay, so if you try number 5, same idea. Here's our reference angle. We're going to first label our sides. What's 18, A, O, or H? What's 15, A, O, or H? O and H, sine, cosine, tangent. So sine of x equals opposite over hypotenuse. So try to do this on your calculator. Raise your hand if you have any questions. 56.44 degrees. Everybody get that? So you're going to do second sine 15 divided by 18, the inverse sine. Okay? Whenever you are looking for the angle measure, you got to remember angle measure means inverse button. Okay? Now, I want to show you something really quickly. Oh, I blew this one way up. So when I was in high school, we actually didn't have calculators with sine, cosine, and tangent buttons on it. They gave us a table that looked like this, a table of trigonometric ratios. The sine of 1 degree is 0.0175. Can you see these numbers, right? The cosine of 1 degree is 0.9998. The tangent of 1 degree is 0.0175. All of the angles are calculated here, 1 through 89. Those are all the acute angles that you could have, right? Now, granted, there's no like decimal, like 32.7 degree angles here, but all of the whole angles are here. So, how would I do my math then if I didn't have a calculator? Well, for example, this one here, I would look up what the cosine of 63 is. Right? Here's 63, right here. Cosine is 0.4540. You see it? Right? So that's what I put, 0.4540. And so in my, I would do 84 times 0.4540. And then I would get my answer. Right? Yep. So sine of a 90-degree angle is 1. Yes. But remember, we're never going to use the 90-degree angle as our reference angle. Okay? And that's kind of a bigger explanation than I have time for. But yes, because opposite over hypotenuse is both the same side. But yeah, we're not going to use 90 degrees. Now, for one like this, how would I use my chart? Well, I know that the tangent of some angle is 23 over 9. So what would I do? I would do 23 divided by 9 on my calculator. I lent out my calculator. Can you just do 23 divided by 9 for me? What is it? Repeating, right? Okay. So now I'm trying to find the inverse tan of 2.555. Well, I go back to my chart, and I got the tangent ratios are the ones that are in the third column, right? This is all 1 point something, 1 point something, 2, oh, here we go, 2.4, 2.6, so 2.55 is somewhere between 68 and 69 degrees. And that's how I would do it. And so what did we get? We got 68.63 degrees, right? So I like showing this chart just because sometimes I think in the calculator it's like this magical so, some little guy in there is figuring it out for you or something. But, well, we all know it's not really a little guy, but this is a chart that it never changes. The sine of 72 degrees is always that same decimal every single time. Okay, tangent, etc. It's a fixed number. Yours is a little bit better because it doesn't round it off after 4 decimal points like the chart does. And so it's a little bit more accurate. Okay, so I'd like you to turn to this page. And I just want you to set up the proportions or the equations first. So for number 1 and 2, they're going to be proportions. For numbers 3 and 4, it's looking for the angle measure. So not a proportion, but an inverse button instead for 3 and 4. And then 5 and 6, also proportions, but be careful, those are a little different than 1 and 2. So set those up first, don't solve. Number 3 should have been sine of x equals 15 over 8. Remember, 18. And remember, that's not a proportion, just an inverse button. And this is tan of x equals 23 over 9. This one should have been sine of 38 over 1 equals 6 over x. And cosine of 51 over 1 equals 36 over x. So if you have them set up correctly, now you can go back and solve them. Remember, if the x is on the bottom, like these two, you're going to end up dividing, right? 6 divided by sine 38, etc. Okay, I'm going to put the answers up here because I think a lot of you already got through them. So this should be 10.8. Oops, I put that in the wrong spot. 10.8. This is 38.1. Oh gosh, 14. And this one was 56.44 degrees. And this is 68.63 degrees. I know some of these are familiar problems, but this one is 9.75. And this one is 57.2. Does anybody have questions? I have a question for you. This is a thinking question. Can the cosine of an angle ever be greater than 1 whole? Why or why not? Can the cosine of an angle ever be greater than 1 whole? Why not? Anybody have a good explanation for why it has to be less than 1? Or actually, could it ever be equal to 1? Ella, what do you think? Exactly, right? The hypotenuse is always the longest side. So if your fraction is something over the hypotenuse, right, then the top number would have to be smaller than the bottom number of that fraction. So it's always going to be less than 1 whole. Wait a minute, I have another question. What about tangent? Can the tangent ever be greater than 1? Tangent is opposite over adjacent. Opposite over adjacent. Could opposite be longer than adjacent? Sure. So the top number could be greater than the bottom number, which would make the tangent greater than 1. Remember this chart here that I just showed you? Look at the tangents. 1 whole, 2 whole, 3 whole, 4 whole, etc. Goes up to 57. Right? So tangents can be greater than 1, but sine and cosine cannot.